Okay, here we are in week 3. We're going to not just talk about business analysis and data analytics, but we're going to look at them in the context of systems. So, systems, as you guys probably have seen from the videos or will see, is a fairly simple concept that gets, I think, complicated by the way we think about them and the way systems are described and understood. The one video pointed out the fact that systems have a negative connotation with many, right? You can't beat the system is rigged, the system is stacked against us. Anyway, the idea of a system is basically components that work with one another to do something. People that discuss and describe systems like to do it via diagrams generally. Here's a fairly simple model of a system. Environment, input, which are the resources that are taken or received or put into the system. Throughput, the process of transforming something into something else. And as you can tell by industry, or as you can imagine, that throughput could involve the production of automobiles or the processing of customer loan applications or the creation of a musical jingle for a commercial. All those things are parts of systems, and that number 3 would represent throughput. Infinite number of ways that throughput could have meaning depending on the work you do. Same with number 4, output. The work of the system exported back into the environment. Environment can be your customer, it can be a consumer customer, it can be a trade customer. For police or a law enforcement organization, it could be something like just processing the case to the next level, to the district attorney, or perhaps recommending dismissal. Feedback is the response to the system. It's the purchase of the product, it's the review or comment on the news story that's been written about a certain subject. It's the acceptance of a proposal by the board of directors. So feedback comes in many forms depending on the activity, obviously. There are lots of systems and system archetypes modeled in this week's reading, or one of this week's reading, which is a 42-page document that looks kind of imposing, but has a lot of very valuable stuff in it. And later on, I'm going to provide you guys with a kind of a recommendation for looking at that document and how to approach it. Because as I say, it's weighty. There are only a few germs that you need from that for this week's exercise, or this week's forum post in particular. But it's a document that I think will be valuable to you, so I would ask you to consider hanging on to it for future professional use. Even though it's a very boring looking document, it's very valuable. So, what is a system? A system is an identifiable, complex, dynamic entity composed of, and this is what's really important here, discernibly different parts or subsystems that are interrelated to and or interdependent on each other, and the whole entity with an overall capability to maintain stability. I'll let you guys look at that for just a second. Key slide, it's from Webster, universally available, but important. One of our readings suggests that it's a set of interacting or interdependent entities, real or abstract. So very close to the Webster definition. All systems contain 4 things: objects or parts, elements. They can be processes, they can be physical inputs. Systems contain attributes. They contain internal relationships. And as we saw in a few slides back, or a few seconds ago, they are all in an environment which they serve and which affects them. One of our videos talked about natural systems, right? That's important to think about natural systems in the context of business or analytical systems too. This is, as you guys see, potatoes. A simple image, right? But it really represents many different potential systems. Obviously, it could be part of a retail system we're selling here or showing here. The retailer has a little goof there, obviously. One of the little yellow potatoes got mixed in with one of the reds. I guess we'd call that an anomaly, right? It's also an agricultural production system represented here. The logistics and the mechanics of producing and delivering tons and tons and tons of little red potatoes to supermarkets in time that for our 4th of July or our holiday or our weekend barbecues, etc., is important. And many systems go into that one grand system. So that's another way of looking at potatoes in the context of a system. And you can really do this with anything. Potatoes, obviously, diet and nutritional. They're part of our diet and nutritional system. In my case, they play probably too big of a part. Got to cut down. You can also look at a single potato as a system too. The single potato, it has skin, it has the fibrous, tuberous part of it, the starch, right? It has pigment. It has a system for regenerating. You leave an old potato sitting around and we all know what happens to it. It starts to grow things. Well, that's part of the system too, right? A few of the most common systems by classification are natural systems, physically designed systems, abstract design systems, things like language, mathematics, statistical notation, chemistry, facts. We have human activity systems, transcendental systems, and this is just really the start. One of our videos talked about autopoiesis and allopoiesis. The autopoiesis is basically a system that kind of runs and manages and maintains itself. I think the speaker gave examples of living things as autopoietic. I can say that some living things, I think, combine auto and allopoiesis. I know my dog and cat need fed, for example, so that brings in the allo. Allopoietic things are things like companies. An organization is really a system. It's a grand system with many other systems. And the allopoiesis is that they need external guidance, management, input to keep running, to establish themselves and keep running. It's not automatic as in the autopoietic. So just a little more amplification or expansion on what was covered in that particular video. The systems approach kind of came about as a way of componentizing things in the highly industrial 50s. Ludwig von Bertalanffy, say that real fast a bunch of times, basically broke things down in order to kind of discover impacts and influence that various components had with other things. And this was part of a general trend in business to improve quality management, improve the speed of industrial production, bring about better results in the flow of work. So this was part of a kind of a general era where a few other great thinkers worked to bring improvement to business. General systems theory applies, is an interdisciplinary application of thinking that views all living and non-living things as open systems. General systems theory is a way to think about open systems. It's a foundation for analysis and modeling, and it gives us a framework for comprehending things like how systems work and interact and affect one another. Because you can't make a change to one without affecting another. You can't change a component without considering that impact of that change on other things within the component. Some common sense stuff here. Systems are goal-seeking, holistic. There's some sort of hierarchy involved. Inputs and outputs, as we saw from the very first slide, is key to any system. Energy is required. Systems are affected by entropy, and we'll get to that in a second in a little more detail. Entropy basically is breakdown, and they have equifinality, which is a final outcome. In a lot of systems, most systems have the ability to proceed in different ways to a finality or a conclusion or the production of something. And of course, systems are impacted by feedback. Again, this gets back to Bertalanffy a little bit. Systems are collections of interacting parts. Remember, and this comes out in the videos and in the readings, that parts are influenced by other parts. All systems, to be understandable and approachable by us, are defined by boundaries. They have limits. They have to be able to be drawn by analysts on a sheet of paper, frankly, to kind of understand how things work. We all see that in our offices from time to time. We are introduced to a new way of managing documents or taking in a new personnel process, new reporting relationships. The kind of company or division hierarchy is probably, to my mind, the simplest and most ubiquitous example of modeling a system. A lot of details left out, obviously, but it's kind of another broad way to look at a system. Interaction outside the system is less influential than internal. That means basically the system serves the environment, and although the environment impacts the system and may be the reason why the system exists, the internal interaction of the system generally impacts the overall performance of the system more than the external. Again, we need to remember to examine the entire system. Systems have inner-directed goals and outer-directed goals. The inner-directed goals are generally those systems that are, or those things rather, that are required to maintain the system, to keep it going, they serve the system. Whereas outer-directed goals are generally focused on an environment, a customer base, something that the system serves. Design strategies are typically outer-directed in that the system is designed to function and or serve the environment. Hopefully that makes sense. Systems are generally goal-oriented. In fact, I think almost every system is goal-oriented, even if the goal is to prevent something. All systems are obviously governed by their purposes. Well, I've seen some that aren't, but that's another matter altogether. Parts operate according to guidelines and they adapt on the basis of feedback. Cybernetics is basically the control and regulation of systems. It would relate somewhat to the autopoiesis or the allopoiesis notion. It basically says that systems have to gauge their effect and make necessary adjustments. So in the context of being a business or a business that uses data and analysis and adjust its approach, the cybernetics would be one way of looking at that. In terms of a simple product, a thermostat would be a good example of a simple feedback mechanism. It gets too cold in your house, the thermostat says, it's too cold in this house. It's supposed to be 72 degrees and it's 76 degrees. I better, well, that was the wrong example. Let's just say it turns it down in the summer and turns it up in the winter, depending on what you have the thermostat set for. So whether you're talking about a simple thermostat that changes the temperature or a process within a company, say the production or the development of a new product, creation of a new industrial design for a new product, to break it down further, we're dealing with things like balance, self-maintenance. We always have issues with deviation from norms, which are generally false and generally require correction. Remember, though, that systems generally can adapt with the notion of there are numerous ways to reach a goal or a particular endpoint. Again, equifinality, the final state that may be achieved in a number of ways. In other words, you can sometimes win an NBA game by playing tough inside, by being aggressive on defense, or you can sometimes win when your three-point shooters are very hot. That's maybe an oversimplification, but in either case, the finality is the win, ideally. And as you can tell, there are more than one way to achieve things. Entropy is, or entropy rather, excuse me, is the, well, some would say it's the natural state of systems. It's the measure of the amount of disorder in a system. In other words, everything disintegrates over time. In the case of a company, a person comes and adds to the department, and maybe morale declines, or someone with a lot of skill or experience or in a managerial position or in a line position leaves the company. That can bring about entropy. Negative entropy or centropy is kind of the breakdown of things as they go. Entropy is offset by a system transforming itself continuously. I would show it on the screen here, but you've probably got it right in front of you. Take your iPhone or your whatever your smartphone is and look at it for a second and think about how frequently you get a system update advisement. A lot of us have our phones set that this happens automatically. Well, this is an example of a system, in this case your iOS system, being updated or modified to deal with a form of entropy, which could be various apps are running in a buggy way on it, or improvements are being made to accommodate more things that Apple or Samsung wants the device to do down the road. All of these things are kind of the notion of repair, maintenance, giving new energy to the system. Again, perhaps an oversimplification, but when we look at systems, we have to really look at everything, which I guess is kind of the point of this week. Which brings us to this. The past weeks have had pretty good video input, and I think the videos in week 1 and week 2 were probably more valuable to you guys than the written material. In this case, this week, I think it's a little bit different. However, the most important reading for the course so far is presented in this rather kind of standoffish, boring-looking 42-page white-on-black slideshow in print. I didn't do it. I'm just bringing it to the party. But my point here is that this is an incredibly valuable document that I think people probably get put off by the initial information, very nuts and bolts, and you have to really be a systems engineer, I think, to start salivating when you go through the first 5 or 6 pages of this. So what I have in my mind anyway, and I thought I would share with you guys, is a system for looking at this document. And uh, I think that the way to approach it is to uh, not read the first pages first, but probably start with page 34 and read to the end of the document, which is page 44. That kind of gives you a broad kind of overview of students or users of business analysis and data analytics to look at the thing and then go back and read from page 1 through 32. It would almost have been better for them to put this up front, but I think they were trying to create a more general document for people that are systems analysts or systems engineers, that sort of thing. So the one thing that I think is most important is to go to perhaps page 42 and read page 42 even before you go to page 34. That gives you information on the big picture, the whole notion that was brought out in the video and in the other reading that we had, that you have to kind of take a holistic view of things, see the fact that nothing functions alone, everything is interdependent. Systems thinking abstraction is the whole notion of things like, well, looking at a system, but then looking at a large system and seeing the first system you were looking at as only a node in the larger system, that sort of thing. Relates strongly to a kind of a big picture perspective. Finally, learning is the ultimate positive feedback loop. And as I say again, this is all on page 42 of that document that I bet a lot of you people groaned when you printed it out. So sorry about that, but I would hang on to this document even after this course just for reflection, and it might help you guys think through things at work. Again, maybe not, and maybe it's just a 42 sheets of paper out of your printer. But I thought it was valuable, even though it's not the most approachable thing. So one of my favorite examples of when systems go bad, and this is something that applies to general business courses, marketing courses. I use it in an advertising course I teach. You can use it in management courses too, or you may have seen this example too, or at least some of you have. What happens when the system breaks down? What happens when thinking and analytics are wrong? The example here is ironically being reprised this summer. I guess Coca-Cola is bringing back New Coke. New Coke is old Coke, or it's an old idea that failed once, and for some unknown reason, the company's bringing it back. I guess companies like to celebrate their failures. Remember Crystal Pepsi from 2 years ago that failed then, and I think it failed in the 1990s when it came out. So pretty soon Ford's going to bring back the Edsel. Just kidding. So in this case, Coke was in its environment reacting to continuing challenge from Pepsi, primarily Pepsi, but other soft drink makers, cola drinkers. It was a formula that this was in the mid 80s, so it would have been around 1984, 1985. Had been around by then for 100 years. They wanted to react to continuing gains that Pepsi was making in terms of market share. So they thought the way to do that was with a flavor that was perhaps closer to Pepsi's in terms of sweetness. Where they got this idea was from their environment. They had recently introduced Diet Coke, well, several years before, as kind of a replacement for their diet drink, which had been called Tab. Although I think you can still buy Tab in some places. It's a cola that was never much good, well, in a lot of people's opinions, but it just wasn't a good tasting cola. You could tell you were drinking a diet cola. So they introduced sweeter Diet Coke, and to replace Tab, essentially. Note the strong name change from Tab to Diet Coke. And they thought, hey, this is great. The sweeter cola drink is really a hit in the environment. Remember our slide about a system being the product in a lot of ways of its environment. So the strategist, to make a long story longer, decided that maybe they should do some product development with Coca-Cola and actually change the flavor of Coca-Cola. They did this by exhaustive taste testing. They had varying degrees of sweetness, varying degrees of sweetness tasted by taste testers and focus groups at various locations around the country and around the world. They got huge buy-in statistically on the flavor that actually matriculated to the top in terms of being the cola flavor that people really thought was good. They were doing this with blind taste test against their old formula, against Pepsi, against other colas, against other possible diet or new Coke formulations. So they thought they had a winning formula based on this input from their system. And in their product development process, they decided that they were going to make this the new Coke. In other words, they weren't going to call it Coke Extra or Coke Sweet or Coke Plus, anything like that. This was going to become the new Coca-Cola, and it was going to replace Coca-Cola. So they did this with much fanfare, as I want to say 1985, 1986, somewhere in that era. And they had the world's most famous announcer, television personality, everybody's father, Bill Cosby. Now, that was in a different era, right? The first reaction would have been, and I had this reaction from some advertising students once, well, and this was fairly recently, well, they shouldn't have picked Bill Cosby as their spokesperson. Bill Cosby was beloved in those days, so that wasn't the error. But so their input was based on the fact that we have a better tasting formula. It's statistically proven. Let's go with it. The throughput was to introduce this as new Coke, the flavor of Coke for now and for years to come. And they brought it out, introduced it with large-scale advertising campaign featuring Mr. Cosby, and the product bombed. There are all kinds of case studies on this, from Harvard Business Review to Forbes magazine to Fortune. So you guys can look this up if you want to know more. As I say, I've talked about this in previous classes because it's the ultimate error in a lot of things, in marketing in general, in understanding customers, and it's an analytics, a market research error. It was the main thing driving it, or the main thing behind it. What the problem was, before we get to the feedback and the reaction to it, but what the problem was is when they were testing all these formulas, they just asked people for flavor preference. They never asked people things like, do you think the flavor of Coca-Cola needs to change? Or would you like this to be the flavor of the new Coca-Cola? In other words, people were testing in a blind, uninformed way, cola flavors. So what they didn't realize at Coke was that there was a tradition that went with the Coca-Cola logo and the Coca-Cola name, the Currier and Ives prints showing people drinking Coke in the 1920s. All that was part of a nostalgia that the testers totally overlooked. So what happened was the feedback. The feedback was, we don't like it. There were groups that organized to save Coca-Cola. People were running to the Wegmans and the Kroger stores of the world and loading up on the last cans of Coca-Cola, supposedly the flavor of which people didn't like as well as the new Coke. So there's a story of analytics, millions of dollars looking for the best results. In market research, this is called a framing error. In other words, they didn't frame the question or they didn't frame the research properly. But following this blunder, they performed probably one of their more brilliant maneuvers at Coca-Cola in effectively using their old formula as a line extension, and they brought Coca-Cola Classic out. So the feedback from the audience, the market was negative within something like 80 to 89 days. And as I say, you can research this in hundreds of different places now. After they announced with great fanfare this new flavor of Coke, they brought out a new Coke called Coca-Cola Classic, which was actually the old traditional Coca-Cola. Within the matter of a year or so, they had completely dropped the new Coke. And within about 2 or 3 years, I think they took the Classic off of the can. So that's how they survived that. Good lesson, both pro and con. And I think the Coca-Cola example is a good example of systems thinking too, and the feedback loops leading to corrections within the system. So there you have analytics, systems, and kind of marketing and marketing research all rolled into one story. That's all for this particular episode.